Hello everyone, welcome back to my YouTube channel. So in this particular video, we'll be talking about the IS 456 recommendations, and we'll be covering the most important recommendations of IS 456. From exam point of view, they may be asked in objective questions or subjective questions like in GATE exam or JE exam or AE or state level exams. And these are also important from interview point of view. So let's begin with our video. So the very first important guideline or recommendation of IS 456 is that EC is equal to 5000 under root FCK, and the values of EC may differ by plus minus 20%. There can be only plus minus 20% of the error in this value of EC. The second is the total shrinkage strain of concrete may be assumed as 0.0003 in absence of any data. If any certain data is not given to you, then in that particular case, IS 456 says that you can assume the shrinkage strain of concrete to be equal to 0.0003. The third point is, as long as stress in concrete does not exceed FCK by 3, the creep is directly proportional to stress in concrete. Till this particular point, till the point of 33% of the FCK, that is the characteristic strength, till this particular point only, the creep is directly proportional to the stress. Above this point, there is no such direct proportional relation between creep and stress in concrete. The fourth point is standard deviation should be increased by 1 Newton per mm square if proper storage of cement or wave batching is not adopted at the site location. If at site wave batching is not adopted or the storage of cement is not proper as per the IS code guidelines, then in that particular case the standard deviation should be increased by 1 Newton per mm square. The next point says that nominal mix should be done only up to concrete mix of M20. Only up to 20 grade of concrete, that is 20 Newton per mm square, should be the characteristic strength up to which the nominal mix should be adopted. After that, the nominal mix cannot be adopted and you have to go for proper calculations. The maximum moment redistribution for indeterminate RCC structures is equal to 30%. Indeterminate RCC structures are the structures in which we cannot calculate the reaction forces without any constraint values. So in that particular case, the maximum moment redistribution value is taken to be 30%. The next point says that the actual concrete cover should not deviate from required nominal cover by plus 10 mm and minus 0 mm. That means the actual cover should not be decreased in any case. It should be minus 0 mm. That means it cannot be decreased at any cost, but you can increase it to maximum by 10 millimeters. The next point is the deflection of a structure. There is some limitation to the deflection of the structure. For the cast in situ case, the deflection of the structure should be less than span by 250, and after the erection and the complete finishing of the member is done, the deflection should not be greater than span by 350 or 20 millimeter in any case. The minimum of these two values should be the maximum deflection of the structure. The next point is the vertical deflection limits for the span of the members. If any particular member has a span of 10 meters up to 10 meters, then for that particular case, the code provides the maximum value of span by effective depth. And corresponding to the maximum value, its support conditions are enlisted. For cantilever case, the maximum span by effective depth can be 7. For simply supported case, it can be 20, and for continuous case, it can only be 26. Now you'll ask, what about the cases of members in which the span exceeds 10 meters? So in that particular case, this value has to be multiplied by 10 divided by span, and also the modification factors should be multiplied with this particular value. Suppose if I say the span is 20 meter and the case is of a cantilever beam, then what will you do? For the since the span is greater than 10 meters, so you will have to calculate the maximum value of span by effective depth to be 7 multiplied by 10 divided by 20, and if some modification factor is also given to you, then you will have to multiply that modification factor as well to calculate the new maximum value of span by effective depth. Now comes the lateral stability condition. So the lateral stability condition is for two cases. One is for simply supported case and another is for cantilever case. So the clear distance between the restraints should be less than the minimum of 60B and 250B square by D in the case of simply supported beam, and the clear distance between any two restraints should be less than the minimum of 25B and 100B square by D. What is B here? B is the width of the beam or any particular member, whereas small d is the effective depth of the beam or any particular member. Now moving on to the next recommendation of IS 456 for two-way slabs of shorter spans. That means the span is limited to 3.5 meters and the reinforcement is Fe 250, that is mild steel. The values of span by depth, here D is the capital D. The span by depth ratios are given for simply supported beam and also for continuous beam. These are the maximum deflection limits for any two-way slab. Remember, this is for two-way slab only, and the loading condition is that the load should be maximum of 3 kilonewton per meter square. So for simply supported case, the span by D ratio is limited to 35, and for continuous case it is limited to 40. This can be asked in any objective question. Now if the steel is not Fe 250, if it is Fe 415 or Fe 500, then for that particular case this value 35 and 40 will be multiplied by a factor of 0.8. Suppose if the slab is a flat slab, then in that particular case this 35 and 40 will be multiplied by 0.9. Now suppose if we say that there is a flat slab and also HYSD steel is used, then you will have to multiply this 35 and 40 by both 0.8 and also by 0.9. Now moving on to the next recommendation. Now this complete recommendation, 12th number, is completely for slabs and it illustrates few recommendations for the criteria for reinforcement and also for spacing. So the maximum diameter that can be used of any reinforcement in a slab should be less than or equal to the thickness of the slab divided by 8. Now the minimum reinforcement criteria is 0.12% of the gross area should be the minimum reinforcement in case of distribution bars, temperature and shrinkage steel. Similarly, it is 0.12% of the gross area in case of main reinforcement bar like Fe 415 or Fe 500. Now the minimum reinforcement should be 0.15% of the gross area in case of mild steel or if we use the welded wire fabric. Now the code also lists out the minimum diameter of the bars to be used. For distribution bars, the minimum diameter should be 6 mm. You cannot use the diameter less than 6. Similarly, for HYSD bars, you have to use minimum 8 mm diameter bars, and for mild steel, you have to use 10 mm diameter bars as a minimum diameter. The maximum spacing of the main reinforcement should be minimum of 3D and 300 mm. D is the effective depth, and for the distribution bars the maximum spacing should be less than minimum of 5D and 450 mm. Now the side face reinforcement is always provided in deep beams. You should be knowing this. So what is the value of side face reinforcement? It should be equal to 0.1% of B times D, that is the area. B is the width and D is the complete depth of the beam. You should remember that it is the depth or it is the effective depth. You should not confuse between both the two. The minimum thickness of the slab should be 125 mm. The slab thickness cannot be lesser than 125 mm. Any slab should have a minimum thickness of 125 mm, that is 12.5 centimeters. Now, how will you categorize a beam as a deep beam or a non-deep beam? This is also illustrated in IS 456 clearly. So if the LE by D ratio is less than 2 in case of simply supported beam, then that beam is called as deep beam. And if there is a continuous supporting condition, then in that particular case, if LE by D ratio is less than 2.5, then that particular beam is called as deep beam. And in deep beam, you will have to provide side face reinforcement equal to 0.1% of the total area of the beam. Now there is a recommendation for column as well. The condition says that bars larger than 32 mm diameter shall not be bundled except in columns. Only in case of columns you can bundle the bars that are greater than 32 millimeter. Like if a bar has a diameter of 36 millimeter, then that bar can only be bundled in case of columns arrangement. But in case of beams, slabs, in slabs you barely use 36 millimeter bars, but in case of beams we can use, but if we use then we cannot bundle that particular bar. The next is the development length LD is increased by 10% for 2 bars bundled, 20% for 3 bars bundled, and 33% for 4 bars bundled. Now if you will bundle 2 bars, then the development length should be increased by 10%. It should be 1.1 times the LD. If you bundle 3 bars, then it should be increased by 20%, and if you bundle 4 bars, then it should be increased by 33%, and so on. The next recommendation is the 18th recommendation. The horizontal distance between any two main bars shall not be less than. The horizontal distance cannot be less than the minimum of these three. The first is the diameter of the bar, if all bars are of same diameter. If in a beam all bars are of like if you say 20 millimeter, then the distance between any two bars, that is the horizontal distance, should not be less than 20 at all. Suppose if you use many diameter bars, then phi max should be the minimum horizontal distance between the two main bars. Similarly, the third condition is MSA plus 5 millimeter. MSA stands for maximum size of aggregate, and since these aggregates should easily pass out from those bars, so we keep a clearance of at least 5 millimeter for that maximum size of aggregate. The next recommendation is that the horizontal distance between bars is reduced to two-thirds of the maximum size of aggregate if needle vibrator is used. If you use needle vibrator, then the horizontal distance should be reduced to two-thirds of the MSA in above case. The next is the minimum tension reinforcement in any particular structure like beams. So it is given by the equation AST divided by BD should be equal to 0.85 divided by Fy. Fy is the yield strength of any particular steel reinforcement. AST is the area of the steel. B and D, B stands for the width of the beam and D stands for the effective depth of the beam. Now the maximum area of tension and compression reinforcement is equal to 0.04 times BD, that means 4% of the gross area. B is the width and D is the total depth. Now for interior spans of slab, for any span that is in interior of the slab and not in the exterior of the slab, then the design moment, the negative design moment, we design for two kinds of moments. Now one is negative design moment, another is the positive design moment. Since there is torsion in the slabs, so there can be negative movement as well and there can be positive movement as well. So the design moment of negative is taken as minus 0.65 and for positive it is taken as 0.35. Unsupported length of the column should be less than equal to 60B if the column is a both and fixed column, and it should be less than equal to 100B square by D if one end of the column is fixed and another end of the column is free. The next point says that when long bars in columns are grouped, phi 2 max should be equal to 20 millimeter. The maximum diameter of the bars, the tie bars we can say, or the longitudinal bars we can say, the maximum diameter of those tie bars is limited to 20 millimeter if very long bars in the column are grouped together. Now there are few recommendations for helical reinforcements used in columns. So if we are using helical reinforcement, then 1.5 extra turns of the spirals are provided. Now maximum pitch in case of helical reinforcement should be minimum of 75 millimeter and diameter of core divided by 6. The minimum of these two will be the maximum pitch in case of helical reinforcement. What about the minimum pitch? So minimum pitch in the helical reinforcement case should be maximum of 3 phi 2 and 25 millimeter. Phi 2 is the diameter of the lateral reinforcement, or we can say the tie rods. Now in case of helical reinforcement, the allowable force PU dash should be increased by 5%, that is PU dash will be equal to 1.05 PU, and Fy max, the maximum yield stress, should be 415 Newton per mm square. Now for longitudinal reinforcement in column of size 200 millimeter and lesser with 12 millimeter diameter bars, the cover should be 25 millimeter. This is clear in itself. Cross-sectional area of the metal core in case of composite columns should not be more than 20%. there are some composite columns made of different kind of materials. So in that particular case, the cross section of the metal core should not be more than 20% at all. Additional movement in design of slender columns. These are the additional movements if we are designing the slender columns. We know the criteria for non-slender columns, but if the column is a slender column, then we will have to introduce these two movements in both the directions. PU LE x square divided by 2000D and PU LE y square divided by 2000B. Now there is one equation, that is biaxial bending and axial load. MUX divided by MU1 to the power alpha n plus MUY divided by MU2 to the power alpha n should be less than equal to 1.0. Now what is alpha n in this case? It is equal to PU divided by PUZ. PU, you are very well versed with what is PU. PUZ can be calculated by 0.45 FCK times AC plus 0.75 FY times ASC. So these are the most important recommendations as per IS 456, and they can be asked in any objective question form or any subjective question form. Like one of the recommendations says that in case of if the bars are bundled, then you will have to increase the development length. Now the question may be twisted in such a format that it has asked you to calculate the development length, and it has subscribed in the question that there are two bars that are bundled. Now it is not directly telling you that you will have to increase the LD by 10%, but by calculating the value of LD, that will not be your final answer. You will have to increase it by 10% since the question is directing that there are two bars bundled in the column. So these are the recommendations that are the most important ones and can be asked in any format. So this is all about this lecture. Thank you everyone.